Hello everyone. The first two-third topics of this course covered the fundamental aspects of programming. Getting a good grasp of those topics will make it easy for you to go through a different intro-level programming course because of the similarities between the topics covered. The last one-third topics will be unique to this course as we are going to focus on data science. Unlike the first two-third topics which build on top of each other, the last one-third topics are going to be independent. We'll be going through a series of lectures focusing on a specific data science topic. In the next two lectures, we are going to learn about a cool and interesting module called pandas. Pandas is going to make all of our lives so much easier. Pandas module offers an easy and fast alternative to all the analysis that we have been doing so far with Python lists and dictionaries. Let me talk about reading for pandas topic. You have two different options to go through the custom reading written by Tyler. Option 1 would be HTML version, which will enable you to passively go through the reading. Option 2 would be notebook version, which will enable you to actively execute the code examples covered as part of the reading. I would recommend you to go through the notebook version of the reading as that will give you an opportunity to try out and make changes to the code examples covered as part of the reading. Click on the code link and pause the lecture video here to download the template notebook file for today's lecture. Since we are going to learn about a module, we'll be taking a hands-on learning approach in the next couple of lectures where we go through the entire lecture using code examples covered as part of the template notebook file. Let me switch over to the notebook tab. I'm going to talk about the learning objectives for today's lecture. Pandas module helps us to deal with tabular data in a better and efficient way. Recall that we have been using list of lists data structure to represent CSV tabular data within Python programs. List of lists data structure is not an adequate alternative to the Excel spreadsheet. Recall that it is difficult for us to process Excel within Python program because of its binary file format. Pandas is going to enable us to bridge this gap here by providing an efficient way of storing and analyzing tabular data. We are going to learn about two new data structures which are going to be series and data frames. In today's lecture, we are going to learn about the series data structure, which will be a hybrid of a dictionary and a list. You might be wondering that we should have both indices and keys if series is going to be a hybrid of a dictionary and a list. That is in fact correct. The only catch is that we'll be using different terminologies. In Pandas world, Python dictionary key is going to be called as index. That is slightly confusing because we have been using the term index to talk about labels for list items. In pandas, list index is going to be called as integer possession. We'll soon get used to this strange terminology. Pandas supports complicated expressions within the lookup square bracket. Recall that we have been using the square brackets to perform list indexing and slicing and dictionary lookups. Pandas is going to allow us to write complicated expressions, and we'll go through examples of that in today's lecture. Pandas also supports element-wise operation. Along with Boolean indexing, element-wise operation is going to enable us to avoid using for loops when it comes to pandas. We are going to be able to replace tens or twenties of lines of code which we have been writing so far to iterate over lists or dictionaries by a single line of pandas code, or at the maximum 2 or 3 lines of pandas code. The objective of using pandas module is to avoid writing for loops as much as possible because we have the powerful tools of element-wise operation and Boolean indexing. Boolean indexing is a complex topic, but we are going to try to understand that using examples. In the next lecture, we'll be learning about data frames data structure, which will enable us to represent tabular data. We are going to build data frames using series. Every column and row within the data frame is going to be series data structure. Before we get started with today's lecture, I want to show you how to create markdown cells. You can insert a regular cell, then click on cell and change the cell type to markdown. Markdown cells enable us to write documentation, which will be very useful. Let me show you the format. You can create title by typing hash and a space. You can create subtitle by typing double hash and a space. Let me show you how to create a bulleted list. You can type in hyphen and then type in the list item. Let me also show you how to create a numbered list. You can type in one dot and then the corresponding list item. CS220 students are not expected to write markdown documentation cells, but it is still going to be helpful for you to know the format in case you want to pursue future personal projects after going through this course. Once you're done typing the contents for the markdown cell, you can execute that like you would execute a regular code cell by typing shift and enter on your keyboard, and that will enable you to get the proper formatting for the documentation. I would encourage you to go through the provided markdown cells. You can do that by double clicking on the cell, which will take you to the edit mode, and you can press shift and enter on your keyboard to execute that corresponding markdown cell. Let's import the pandas module. Recall that you have installed pandas because you installed Python using Anaconda. Just in case if the statement import pandas does not work on your laptop, I would recommend you to try to install pandas by typing in pip space install space pandas within your terminal window. This command might or might not work within the Jupyter notebook depending on how Jupyter is configured on your laptop. It is better for you to try it within terminal or PowerShell window. How can we access series? We are going to type in pandas, which is the module name, dot, and then series, which is the data structure name. S is going to be capitalized here. Pandas is a very famous module. Because of that reason, people usually use an abbreviation to perform the import. Let me show you how to do that. You're going to type in import space pandas, then you're going to type in the keyword as, and then the abbreviation is going to be PD, which is the most commonly used abbreviation. We can now use pd.series to access the series data structure here. You can create a series object instance either from a dictionary or a list. Let me show you how to create a series from a dictionary. I have a dictionary example variable D here, which is storing three key value pairs. The keys are strings 1, 2, and 3. The values are integers 7, 8, and 9 over here. Recall that you can create object instances by using parentheses. That's exactly what we are going to do to create series object instance as well. So I'm going to type in pd.series. Within the parentheses, I can pass dictionary variable d as argument, and that's going to enable us to create this series over here. Instead of using a dictionary variable, we can type in the entire dictionary within the parenthesis, which is going to be the constructor call for series over here. Let me capture the return value into a variable as, and I'm going to display as. We are going to talk about this vertical representation for series here. On the left hand side, you see the index for the series, which are going to be keys within the Python dictionary that enabled you to create that particular series. On the right hand side, you see the corresponding values, which are going to be values from the dictionary. You do not see integer positions here, so I'm going to talk about that really quickly. So let me type the output from the sDisplay command over here. You do not see integer position, which I'm typing as IP. The next set of values are going to be the index, and finally you have the corresponding value. For the value 7, your integer position is going to be 0. Integer positions begin with 0 and get incremented by a value of 1, just like how indices get incremented by a value of 1 starting at 0 when it comes to Python lists. For the value 8, your integer position is going to be 1 and the corresponding index is going to be 2. And for the value 9, your integer position is going to be 2 and the corresponding index is going to be 3 over here. After the display, you have something which is called as D type. D type refers to data type. The data type here is being displayed as int64. This data type is actually not coming from Python. Internally, pandas uses the C programming implementation. In C programming language, the regular integer has 32-bit length, which will enable you to store 2 billion numbers. Int64 refers to 64-bit integer, which will enable you to store 4 billion numbers. Because of the internal implementation in pandas being with C programming language, you might see some of the data types which are from the C programming language. You're not expected to know anything about it, just be aware of the fact that you'll see things like int64, float64, and so on. Let's talk about how to access the values here. Recall that we can look up a key's corresponding value within a dictionary by saying D of that particular key. We are going to get the value as 7 here because the key 1 maps to the value 7. So how can we access values when it comes to series data structure? We are going to use the .loc lookup, where we are going to pass the index as argument to look up the corresponding value. So I'm going to say s.loc of 1 here. Recall that indices in pandas world are going to be keys from the dictionary. So LOC is going to make us mention the pandas index of 1 here, and that will retrieve the value of 7. If I say s.loc of 2, that's going to retrieve the value 8 here. LOC stands for location lookup. Let's talk about how to use the integer positions. We are going to use .iloc to access the integer position lookup. So I'm going to have to mention s.iloc. So if I specify 0, that's going to retrieve the value 7 here. If I specify 1, that's going to retrieve the value 8 here. And if I specify -1, that's going to enable us to retrieve the last value, which is going to be 9 here. You can use negative integer positions, just like how you can use negative indices when it comes to Python lists. Let me show you how you can perform the lookup without using ILOC or LOC keywords here. So you can simply specify S open square bracket close square bracket, and within that you can either specify integer position or an index. I'm going to use an index here by saying S of 1. You can also say S of 0. The only problem with this particular version of the lookup is that it is not very evident whether you're mentioning an integer position or an index for the lookup here. So it is always better to use LOC and ILOC. ILOC stands for integer position location lookup and LOC stands for location lookup. If there is conflict in terms of the usage with S open square bracket close square bracket in terms of whether that represents an integer position or an index, pandas by default assumes that you're talking about an index and not an integer position. I'll wrap up this video here. In the next video, we are going to talk about accessing multiple values within a list of integer positions.